It's been a while since we looked at how artificial intelligence is going to kill us all. And I have to say, AI's made remarkable progress at taking over the world. The first good news for AI was that pretty much the first thing Trump did after his inauguration was to revoke an executive order from the Biden administration on addressing AI risks. The purpose of that order was to require AI companies to conduct safety tests if their systems pose risks to US national security, the economy, or the public. Seems like a reasonable idea to me, but it's gone now. Then the Chinese company DeepSeek came out with their reasoning model R1 that rapidly outcompeted everyone else in terms of bang for the buck. In response, Americans are largely giving up even pretending to be cautious about AI development. It's all about competition now. Safety is falling by the wayside. At the end of January, Stephen Adler, an OpenAI safety researcher, left the company. In a post on X, he wrote, "I'm pretty terrified by the pace of AI development and that the global race towards artificial general intelligence is a very risky gamble." He isn't the first to leave OpenAI for that reason. By August last year, reportedly, about half of the AI safety people had left the company. Several of them publicly criticized OpenAI's low safety standards. It didn't help that it turned out DeepSeek has basically no safety measures, which is one way to cut costs. A group of AI safety researchers used an automated attack methodology on DeepSeek R1, which tested it against 50 random prompts that include cybercrime, misinformation, illegal activities, and general harm. In their own words, the results were alarming. DeepSeek R1 exhibited a 100% attack success rate, meaning it failed to block a single harmful prompt. Other groups drew similar conclusions. DeepSeek also leaked some user information into a publicly visible database. One could say it's open source with an open sync. A week ago, Google dropped their pledge to not use AI for weapons or surveillance because I guess they don't want to lose out on business. Because just a few days earlier, OpenAI had announced that they'll support American national labs, among other things, in matters of nuclear safety. Yes, you heard that right. In a press release, OpenAI writes, "The labs also lead a comprehensive program in nuclear security focused on reducing the risk of nuclear war and securing nuclear materials and weapons worldwide. This use case is highly consequential, and we believe it's critical for OpenAI to support it as part of our commitment to national security." I'd argue it's somewhat premature to put AI in charge of nuclear weapons before it's learned to not make up shit, but I guess I just don't have the right entrepreneurial spirit. One who certainly has the right spirit is Elon Musk, who's currently busy taking over the US government. Thomas Schett, a former Tesla engineer and now head of the Technology Transformation Services, has declared that the path to government efficiency goes through AI. According to 404 Media, he said that this would, among other things, include AI coding agents that write government software. Meanwhile, on the research side of things, scientists have found that even the current large language models, dumb as they still are good at in-context scheming, by which they mean it's not difficult to instruct the models to lie to a third party, a feature that I have no doubt will make them greatly useful in government. Another group has found that several large language models, when instructed to adjust their guardrails for harmful content, will merely pretend to do that, a tactic they call alignment faking. In this test, they told the models which queries were part of the training. The models then did as instructed on those training queries, but not on others, reasoning that this way the model weights wouldn't have to be adjusted. In other words, the models resist being retrained. The authors explain it this way. While we made alignment faking easier by telling the model when and by what criteria it was being trained, We did not instruct the model to fake alignment or give it any explicit goal, as future models might infer information about their training process without being told. Our results suggest a risk of alignment faking in future models. And then I have a final cheerful paper for today, this one from a group of AI safety researchers who warn that the most likely way things will develop is not a sudden takeover, but a gradual disempowerment of humans. They say that what's going to happen is that we'll let AI perform increasingly more tasks to manage financial, political, and economic systems. If AI is more efficient than humans, and if we demand AI to be efficient, then we're engineering ourselves out of existence, not because of the way we code AI, but by the tasks we give AI. This, unfortunately, sounds all too plausible to me. I'm not an AI doomist. However, I think we need to take this seriously. Humans are bad at foreseeing emergent behaviors in systems with large numbers of interacting agents, whether those are humans or AIs. And once we have more or less autonomously working AI agents all over the place, intelligent or not, it'll not be as easy as pulling the plug. So what are we to do? Maybe we could ask an AI. I sometimes wonder if not there's some physics fix for climate change. Self-replicating nanobots that collect carbon dioxide, artificial super trees, or clean energy from the vacuum. Then I wake up. But today I have a paper from a physicist who knows how to make dreams reality. He's figured out how to slow climate change with nuclear bombs. A worldwide nuclear war would, besides killing a lot of people, also blast huge amounts of ash into the atmosphere, which would cool the entire planet. This nuclear winter, as it's called, would result in crop failures and could kill billions of people within 5 to 10 years. That's one way nuclear bombs could fix climate change. But it's not what the new paper is about. Instead, the new paper is a plan to save the world that, leaving aside the thing with the bomb, is actually quite modest. It's an idea for carbon dioxide removal known as enhanced weathering. Weathering is the process by which some minerals naturally absorb carbon dioxide and bind it. The common way of doing this is to produce a lot of these minerals, grinding them, and then distributing them over large areas of land. But it's expensive to produce that much stuff and cumbersome to distribute it. That's where the nuclear bombs come in. The author suggests that we place a nuclear bomb underneath the sea at several kilometers depth in an area with a lot of basalt. This is a type of rock that naturally absorbs carbon dioxide. All that water would absorb the shock of the explosion, and ocean currents would then distribute the basalt. This would suddenly make a lot of water very good at absorbing carbon dioxide. And the oceans take up a lot of carbon dioxide from the atmosphere. So the carbon dioxide goes into the water and then into the finely distributed rocks and stays there. The author estimates that an explosion with a yield of about 81 gigatons TNT equivalent could undo 30 years worth of carbon dioxide emissions. That would result in a temperature decrease of roughly 1.5 degrees Celsius. It'd be substantial. He estimates the cost with $10 billion. That doesn't even buy you a Twitter on a rainy day. He's even picked a location that's the Kerguelen Plateau, basically in the middle of the Indian Ocean, home of the Kerguelen Islands, also known as Desolation Islands, uninhabited except for some French soldiers who use it to try new baguettes on penguins. But you won't be surprised to hear that there are a few problems with this idea. One is that 81 gigatons is about 1,000 times larger than the biggest nuclear bomb ever detonated. This was the Tsar bomb, a hydrogen bomb that the Soviets blew up in 1961 just for show, basically. Basically, it had a yield of about 50 megatons of TNT, about 3,000 times more powerful than the Hiroshima bomb. For this new proposal, we'd need a bomb that's another 1,000 times larger, so that's 3 million Hiroshima bombs. There are also some safety concerns, such as radioactive contamination of the seafloor. What happens if that explosion blasts a lot of water vapor, also a greenhouse gas, into the upper atmosphere, or what all that basalt would do to the oceans? Though it's a naturally occurring and rather inert substance, but maybe we shouldn't trust physicists on this. And no one asked the fish. This isn't the only world-saving tech idea that scientists have come up with over the years. One impressive idea is to build big chimneys that'll be some kilometers high and basically give the heat on the ground a better escape route to space. I like this idea because such a chimney wouldn't only cool the planet, it'd also produce energy because the warm air wants to rise. The inventor of the idea has a prototype that's about 4 meters high, so now we just need to make this 1,000 times larger. Problem solved. A similar proposal is to let warm air rise up in balloons and then release the air at high altitude. That'll take a lot of balloons, though. Another world-saving idea is to put giant mirrors into space between us and the sun to reduce the energy that our planet absorbs. It has a similar effect as putting tiny particles into the stratosphere, but has the advantage that by moving the mirrors, the effect can be adjusted. These ideas all have a similar problem, and that isn't the cost or even the enormous scale and necessary material. No, the major problem is that they'd all require cooperation among many people. And lack of cooperation is exactly the reason why we don't manage to phase out fossil fuels in the first place. Though I doubt it's going to happen, I personally very much like the nuclear bomb idea, and I'd say go for it. What's $10 billion among friends? At the very least, we'd get an amazing bang for the buck. The universe was created with the Big Bang, at least that's the current theory. But where did the laws of nature come from in the first place? Today I have a very interesting paper that puts forward a possible explanation. The paper is boldly titled How to Make a Universe by Paolo Bassani and João Maguejo. It's a new mathematical framework for the evolution and natural selection of laws. They allow random changes to the natural laws and show that, if one does this, the universe eventually settles into the stable, ordered space-time with matter that we observe today. In a nutshell, they give mathematical support to the idea that our universe might have been born out of chaos. It's worth looking at the details. What they actually do is not let the laws in their entirety evolve. Concretely, they allow the constants of nature to change, or I should say more precisely, that what we think are constants of nature. These constants are, for example, the strength of gravity, or the strength of the electromagnetic interaction, or the masses of particles. They also allow the speed of light to change and even more boldly say that the speed of light could once have been different from the speed of gravitational waves. In Einstein's theories, they're always the same. And all these constants, so their idea, could have started from any value in the early universe. Then they allow small random changes to the constants, and these changes in return affect the frequency at which the constants change. If you let the constants of nature vary, you'll violate all kinds of conservation laws, most importantly energy conservation. So if you allow the constants of nature to change, you can create matter out of nowhere. This is an interesting idea for how our universe might have begun. At present, physicists assume that all matter and energy in the universe was created from the decay of a mysterious field called the inflaton field, for which, alas, there's no evidence. Most intriguingly, what they say in the paper is that if one allows the constants of nature to change this way, one finds stable pockets in which the constants become, well, constant. You can see in this figure that after a lot of initial fluctuations, the values become stable. And one of the criteria to make that happen, they say, is that we have a neatly ordered space-time that can bend and curve under gravity, but no spontaneous creation of matter and no non-local infinite speed interactions across the universe. The reason is that in these cases, the mutation rate for the laws of nature would remain high. To give you an analogy, think of the constants of nature like grains of sand sprinkled on a plate with a speaker underneath it. The sound puts the plate into motion and makes the sand randomly jump around. But where the plate doesn't move much, there's not much jumping. So in those areas, the sand piles up. That is, the stable states in the end are those that are unlikely to randomly change. In the paper, they say that this is why our universe is the way it is, with conservation laws and causality and a finite speed of light. Let me be clear, though, that they didn't say our universe is unique for what the values of the constants are concerned. This isn't the point of the paper. They're concerned with why the constants aren't changing. A similar idea was put forward about 30 years ago by Lee Smolin, who called it cosmological natural selection. Smolin said that the constants of nature change inside of black holes, and black holes then create a new universe with a different set of constants. In the new paper, they don't use anything with black holes, and they don't produce new universes either. They just assume that the constants can change somehow. João Maduejo, one of the authors of the paper, by the way, also coined the term axis of evil for some suspicious alignments of CMB patterns. He's generally good with words and has written two most recommendable books, one about his fight with the cosmology mainstream, about accepting changes in the speed of light, and one about the life of the physicist Ettore Majorana, who mysteriously vanished. My most vivid recollection of João was the day he yelled "F you" all through the PI lobby. Hey João, in case you're listening, as you see, you left an impression. Maybe more importantly, João is a rebel by nature, and he has the technical skills to convert that rebellious spirit into solid theoretical work. I don't know if he's on the right track with this, but I think it deserves being taken seriously. We really need to do something about the vocabulary, though. Changing constants sounds seriously funny. Artificial intelligence has an energy problem. Indeed, if you listen to Donald Trump, then the United States has an energy emergency. Experts advise citizens to conserve energy by staying off Twitter until further notice. More seriously, one of the biggest tech hopes for clean energy has for a long time been nuclear fusion. And among the nuclear fusion startups, the one that's attracted the most attention is Helion Energy. Is that attention justified? Let's have a look. Helion Energy made headlines last week for raising another $425 million, which puts its total funding above $1 billion. Helion is a privately owned company. Its probably most famous backer is Sam Altman, the CEO of OpenAI. Helion was founded in 2013. In 2014, they wrote on their website that they aim to have a commercial plant operational in 6 years. 6 years later, they still aim to have the plant operational in 6 years. Come 2022, and they want to get it done by 2024. The website now says that they want to get it done by 2028. Let me just say, I'm a little skeptical. Helion uses an approach to fusion called field reversed configuration that, while not new, is only pursued by 3 startups: Helion, General Atomics, and TEA Technologies. These field reversed devices are basically particle accelerators. You accelerate a bunch of fuel particles with magnets and then collide and compress them in the middle. That compression increases pressure and temperature and fuses the nuclei. The energy released on the fusion creates very fast-moving particles. One then has to find some way to harvest that energy. To give you a sense of scale, nuclear fusion reactions typically take place in the range of 10 to 100 mega-electron volt of energy per particle, about 1 million times less than the energy that the LHC uses, which is why the Helion device is just a few meters long. What's special about the Helion approach is that they want to generate electricity directly from fast-moving charged particles in the plasma. You see, in approaches using magnetic confinement like ITER, one generates heat, and the heat then has to be used to create electricity. This is also the case for inertial confinement, where one shoots at fuel pellets either with lasers or particle beams or solid bullets. This detour from nuclear energy to heat to electricity is far less efficient than going from the fast-moving particles directly to electricity. Helion's is a pulsed approach, not a continuous one, and the fast-moving charged particles rapidly change the magnetic field, which induces a current. So that's the advantage. The disadvantage is that the fast-moving particles need to be charged. Now, in the usual nuclear fusion reaction, one uses deuterium and tritium as fuel. This releases fast-moving neutrons. Yes, one also has charged particles, of course, because the electric charges need to go somewhere, but the fastest moving particle, that is neutral. So that doesn't help Helion much. This is why Helion, as the name suggests, wants to fuse helium-3 with deuterium, because this releases a fast-moving proton, which is charged, and they can then extract the energy from that. Sounds good, but there's a reason why no one else uses helium-3 as a fuel for nuclear fusion. It's because the energy threshold is about 4 times higher. With that in mind, have a look at this 2021 press release from the Helion website. Helion Energy today became the first private company to announce exceeding 100 million degrees Celsius in their 6th fusion generator prototype Trenta. Reaching this temperature is a critical engineering milestone, as it's considered the ideal fuel temperature at which a commercial power plant would need to operate. Note how carefully they write that. It is considered the ideal fuel temperature, and not that they consider it to be ideal. That's because it's considered a pretty good temperature for a reactor that runs on deuterium and tritium. For the helium fusion which they need, that's pretty low. There's also the question of where the helium-3 comes from, because that particular isotope is very rare on Earth. Helion wants to create the helium-3 from deuterium collisions, and while that's possible, it'll reduce the efficiency of the entire cycle. Finally, there's the general issue that the nuclear plasma motion can become unstable, which will lead to losses and also make net energy generation more difficult. Generally, the company has been very secretive. They have, for all I can tell, not published any technical reports, so really we have no idea what's going on. I've little doubt that they can generate nuclear fusion reactions in their devices, but I strongly doubt that they're anywhere near break-even. That leaves the question, why is this company in particular so extremely well funded? Do the investors know something that we don't know? Is it re-engineered alien technology? Are they secretly building a portal to a parallel universe? Or is it maybe wishful thinking? Let me know which one of those you think is most plausible. Thanks for watching. See you tomorrow.